Today's video is going to cover problems from section 8.2, which is with arithmetic sequences. So I'm going to go over number 7. On number 7, they give you the sequence of 1, 2, 3, 4, and 5, dot, dot, dot. That means there's an infinite number. We're trying to decide if it's arithmetic, and if it is, then what the common difference is. If it's arithmetic, you will be able to add the same amount from one term to the next term. So since it has a constant amount of being added of 1, it is an arithmetic sequence. And the common difference, or D, equals 1. Now let's look at number 8. So on number 8, here's our sequence: 1, 3, 5, 7, and 9. Again, if there's a common difference, so this one we keep adding 2 to get to the next term. It's a constant amount, it's what you add each time, so it is an arithmetic sequence, and the common difference, or D, equals 2. Now let's take a look at number 21. So on number 21, they give us the sequence of 5, 8, 11, 14, and 17. It asks us to find the nth term of the arithmetic sequence. So for this, we're going to find the equation or the formula that could figure out any term. So here's what we're going to use. We're going to use a subscript n equals a to the subscript 1 plus n minus 1 times d. So on this one, we want to figure out what the common difference is, or d. So the amount being added each time is 3. So that is our d value. So d equals 3. So on this one then, the first term, or a subscript 1, is just always going to be the first term that they give you. So a subscript 1 equals 5. So we're going to substitute in and simplify. So the nth term can be found. So a subscript 1 is 1 plus n is what we don't know. We don't know how many terms are going to be. So n minus 1 times d, which is 3. So then we're going to simplify. So distribute the 3. So we have a subscript n equals 5 plus 3 and minus 3. Combine like terms. 5 minus 3 is 2. So it would be 3n plus 2. So that would be the way to find any term, or the nth term. Now let's take a look at number 32. So on number 32, they tell us what the third term is. So they tell us the third term is 15, and the 21st term is 87. So on 32, again, we're trying to come up with the formula for the nth term. So we will be using this again. A subscript n equals a subscript 1 plus n minus 1 times d. So one way to do it, if we know the third term is 15 and the 21st term is 87, I'm going to utilize this to find the common difference. So on this one, I'm going to take 87 minus 15 to figure out how many numbers it's going to in between there. So 87 minus 15 is 72. And I'm going to divide by whatever 21 minus 3 is. So 21 minus 3 is 18, because there are going to be 18 terms in between there. So 72 divided by 18 equals 4, which means the common difference is 4. Each term will go up by 4. So we know what D is. The first term, I'm going to work backwards to figure out what the first term is, or a subscript 1. So working backwards, 15 minus 4, because this part here would be decreasing, is 11. And then 11 minus 4 is 7. So this would be our first term. And I use this common difference to figure out what the first term is. So now I'm going to substitute in to this formula. So the nth term can be found by using the first term, which is 7, plus n minus 1 times the difference, which is 4. I'm going to simplify. So a subscript n equals 7 plus 4n minus 4 7 minus 4 is 3. So the way to calculate any term would be to take 4 times n and then add 3. So there would be the answer. Now I'm going to look at number 38. So 38 asks us to find the sum. So we have of the sequence. We have 2 plus 4 plus 6 plus numbers in between, and then the last term is 102. So these would be the terms that we know. So on this one, we're going to use the summation. So to find the sum, you can take n and divide by 2, and then you multiply that by a subscript 1 plus a subscript n. So on this one, we do not know the number of terms, so we need to solve for n. So to solve from n, we're going to substitute into this. A subscript n equals a to the first plus n minus 1 times d. So a subscript n is going to be the last term here. So this is your a subscript n. So the last term, I could also have used one of these terms. I'm just going to use this one. So 102 equals the first term, which is what a subscript 1 is. So 2 plus n minus 1. We can see these first terms are going up by 2. So that is our common difference, times 2. So I'm going to simplify and solve for n. So 102 equals 2 plus 2n minus 2. 2 minus 2 cancels out. Divide each side by 2. So the number of terms is going to be 51. So now I'm going to use that, and I'm going to substitute into the summation, or the way to find the sum. So the sum is going to be found by taking n, which is 51, and dividing by 2, and multiplying that by a subscript 1, which is 2, plus the last term, or a subscript n, 102, and that will total up to 2,652. Thank you.